Next feature speaker, topic is big data, the next frontier for improved ag productivity. We all know in this space, there's a lot out there, and it's about how we bring it back to our own operations and turn it into something that's viable for all of us. Anyway, I'd like to ask Mick Keogh from the Australian Farm Institute, Executive Director, to come and talk about big data, an intro to the latest buzzword in ag. Thanks very much, Mick.
Sorry. Be a bit embarrassing talking about big data if the computer wouldn't work, wouldn't it? That's right. Okay, got it. Thanks very much. This work we've been doing in this area is part of a project that's being sponsored by the Cotton Research and Development Corporation, Grain Growers Limited and Dairy Australia. And all of those organisations are obviously interested in where the developments in relation to data associated with agriculture are taking us and what advantages or opportunities that might provide. And I thought it was quite interesting in this regard, the significance of these developments. Some are likening it to the Green Revolution, so that the data revolution or the digital revolution in agriculture will be the equivalent to the Green Revolution in the 60s and 70s in terms of the increases in productivity. And I guess I got a sobering exposure to that sort of thinking in talking to one of the major agricultural biotech companies in the US, and they revealed that over the last 12 months they've put on about 100 data analysts and only 1 or 2 plant scientists. So their commitment and their investment in data in that respect is probably 50 or 60 times what their investment is in plant science at the moment, in terms of trying to come to grips with the role that big data might play in the future of agricultural productivity. So it's certainly an interesting development and brings it to down to earth in terms of where the developments are going. There is, as is usual in these things, some need to be clear about what we're talking about. Big data is a term more generally used and is being applied across a whole range of different industries. And in fact, any of you that have got shopper dockets from either of our friendly retailers will in fact be participants in big data. That's one of the main reasons they have those dockets, those loyalty cards, to track what sort of purchases you make and to crunch very big databases to work out where to put products and what products where, and if you buy this, what else will you buy, all those sorts of things. So big data, when we're talking about it in terms of agriculture, is analysing and looking at databases where the scale and the volume of data are such that you can't just pick up information out of it easily. You do have to be able to pull it apart. Digital agriculture is probably what a lot of people talk about more, and that is the use of small amounts of data in relative terms at the farm level to help make production decisions. Now the two are related, and I'll give you an example. So an example of big data would be the analysis of all the yield maps from all the cotton harvesters operating in Australia over a 5-year period, together with weather data and irrigation water use data, to identify yield and water use efficiency trends. So that would be a big data project. And that would be an application of big data with obviously a lot of data storage and number crunching capacity associated with that. Digital agriculture might be an example of the use of 5 years yield maps from a specific paddock by an agronomist to develop a variable rate planting and fertiliser strategy for that particular paddock. Now, of course, the link between the two is the big data analysis might turn up particular varieties of cotton, for example, that feed into the sort of recommendations that the grower might receive from the agronomist on the basis of the analysis it's carrying out there. So a lot of the discussion is really about digital agriculture and the application of data to farm management decisions, but in many respects, a lot of the bigger issues are informed by analysis involving big data sets. So I guess we need to be clear what we're talking about. The evolution, if you like, of this sort of information and technology, you can track it that you had an original product, a tractor, and it was just an engine and four wheels. You then moved on to a smart product which had IT capacity built in. You then moved on to a connected product. So we now see tractors that are internet enabled and on a link back to a manufacturer or whatever. Then you're getting to product systems where, for example, there's a computer system, a software system supporting that for example, can identify a service need, can identify a replacement part, can identify issues with the performance of that tractor. Then finally, we're now getting onto a system of systems where that particular farm equipment system would in fact interact with a larger farm management system that it might involve collection of weather data, collection of data about different varieties and how they perform, collection of data around water, and integrating that all into a farm management system. So where the development of this is at the moment is towards this area here. So we've got the smart equipment, we've got irrigation systems, for example, and we've got soil testing and other things that can populate all this information, and now the developments are around how do we integrate that into something that makes sense at the farm level and that can help you or an individual make decisions. So that's really where we're up to. And I'll come back to this later, but one of the fascinating quandaries about this whole area is that, and some of you may have experienced this already, an individual yield map for an individual paddock in an individual year is interesting for about 5 seconds. But it doesn't actually tell you much. Yield maps for the same paddock over a period, which you can use then to work out where particular production zones or treatment zones might be in a paddock, starts to become more valuable. But then if you can actually put together a huge database of yield data from a whole production region or state or even at a national level, then you can generate enormous value out of the information and the insights that come out of that sort of analysis, now that we have the capacity to handle data of that sort of volume. So this is one of the quandaries around this whole big data issue, and I'll come back to it. The more individuals want to keep the data private to themselves, the less value it is. So that's something to think about. Okay, so where are we at? The ultimate objective, I guess, is to develop systems that allow you to integrate a whole range of multiple layers of information. So things like yield maps, rainfall data, historical and recent temperature, soil type, soil nutrient status, slope, seed variety, fertiliser, all those sorts of things, and integrate all that information in a platform which then ideally is driven by an algorithm or algorithms that allow the integration of all that data into something as specific as a map for variable rate application of seed or fertiliser or whatever. So in other words, somehow finding ways to integrate all these various layers of information, which of course all have multiple dimensions to them, use the storage and the processing power of microprocessors, use the learnings from research, from development, from farm practices, from all those sorts of things to integrate all that and end up with, for example, a recipe for a variable rate planter or something like that. So that's the ultimate objective, I guess. A lot of us would look at that and say, well, that's a pretty big ask, and I think that's the reality of the situation, that That's the challenge, and there's certainly a lot of developments happening in that area. It's starting to move towards that, but there's a bit of a way to go in a lot of respects. So if we look at the sort of developments that are occurring, they're driven by two things. One is a range of different products and services that are all part and parcel of this sort of matrix. And then the other side is it's the technology that allows that to be delivered or driven onto the ground. So if you like, this is the software and the operating systems, and this is the iPad or the smartphone that allows it to be delivered on the ground. So if you look at the sort of developments that are occurring, and particularly in relation to the US and through the Corn Belt, precision ag equipment, that's certainly growing in terms of the capacity of individual equipment to generate data and to capture data around specific activities. Then there's also developments around the storage and processing of that information. So My John Deere, for example, Trimble and Ag Leader all have cloud storage and data handling capacity associated with the collection of data from often the equipment that they manufacture. And then the third level of that is the delivery system. So how do you get that information back to something that's useful on the farm? And so obviously the Trimble IT equipment that's in a tractor's cab, or the iPad applications and those sorts of things are the way that the useful insights out of this sort of information gets delivered back onto the ground. So if you look at the various players, there's probably 200 or 300 companies involved in this space, certainly quite active in the US, and it's certainly seen as the next growth area of generation of revenue for some of the ag companies that you'd be very familiar with. It's interesting to me that when you look at where the activities are happening, there's a lot of activity around data storage and retrieval. So a lot of software models where you can keep paddock records, keep treatment records, keep yield maps, and retrieve that information. So it's really just a data warehouse, if you like. You store the information. You might be able to store multiple years of information there, and you can retrieve it. There's also a lot of activity around software for retailers. So remembering in the US, most of the input supplies come from a co-op or a local retailer, and so a lot of the focus has been on equipping the agronomists or the crop advisors associated with those with software packages that are probably more focused on bringing about product loyalty. In other words, making it easier for that agronomist to recommend a particular fertiliser or a particular crop variety, and then record orders for fertilisers, schedule spraying, all those sorts of things. So there's a lot of activity around there. When it comes to actually models that can help in decision making, that's a much harder issue. Certainly the data's available. There's probably only 2 or 3 players really that are involved in delivering decision support tools that use all that information and come up with some recommendations. So FarmLink and True Harvest, I'll talk a little bit about what they do, is one example. Climate Basic, which is the standard product offered by Climate Corporation, owned by Monsanto, is another one, and AgSolve is another one that has some smarts in it. But it's interesting to me that this hard bit, in other words, this making sense of all this information to help actually make decisions and developing those algorithms that allow that to occur, is probably the area where it's certainly a much harder task, whereas there's an awful lot of software products that simply capture data and allow you to retrieve it without necessarily helping you to make decisions. And in fact, it's interesting to me that what you typically see is either the crop advisor or the farmer themselves sitting down with that information and then manually mapping out, for example, variable rate zones on a paddock, rather than allowing this information to actually predict how that different zones in a paddock should be treated. So it's getting from having a lot of data stored and available to how do I use that in decision making, which is, I think, the real challenge, and that's where there is a bit of action happening, but it's certainly at the hard end of the spectrum rather than this middle area where there's an awful lot of different products available. So as I said, there's a couple of hundred companies operating in this area in the US. Virtually all the new crop machinery is data enabled, much is internet enabled. It's a large and competitive market for data storage and management. Companies like Amazon, IBM, all those sorts of companies are offering storage capacity. That's pretty generic. Retailers and seed companies are competitive in providing software tools. Often they have a product loyalty focus. So in other words, here's a prediction of how our fertiliser will perform in your particular situation, those sorts of things. But only a few players have developed the predictive modelling capacity, and there's also, obviously, as we see here, a lot of competition around farm accounting and farm management software. That's pretty standard in the States. If we look at some of the examples, Climate Corporation, as I said, owned by Monsanto, has this year offered a Climate Basic, which is a downloadable app from the iStore. Once you put in your coordinates, it keeps detailed weather information and makes it available to you. And probably the main tool on it is this nitrogen depletion modelling tool, so that you can put in, for example, where you intend to apply nitrogen at what time of the year, and it will give you a predictive model of the depletion rate of that nitrogen and the availability of nitrogen to the crop. So that seems to be the main functionality of that at the moment. The Climate Pro is available, and you actually pay a subscription for that, and it includes access to things like NVDI satellite data that tells you more about the health of the crop and those sorts of things. Interesting enough, on the Climate Basic, when Monsanto or Climate Corp released it, they had 40 million acres sign up within about 3 months. So about 40% of the US corn crop, the growers signed up to use that basic application, and it doesn't do much more than tell you the weather and give you a tool to estimate how much nitrogen you need to apply. FarmLink True Harvest is a slightly different model. It's one where the company is in fact a fairly major contract harvest supplier, and they realised that the data, the yield maps in their contract harvesters provided them with some pretty valuable information that they could use in benchmarking. They then discovered, of course, that the calibration around the yield monitors in harvesters is pretty rough and ready. So they developed a QA system to sort that out, and now provide a service where, because they can identify the particular soil type, the particular climate, the particular location and the yield of the crop that they've harvested for you, they can also provide you with benchmark data about how your crop performed compared to very similar crops in other fields, and they get it down to about 50 square metre units of land. So it's quite a detailed benchmarking type product that's very much ground truth on the basis of yield data from the harvesters. John Deere has entered the sphere as well, initially capturing machinery performance data, but more recently with the myjohndeere.com website, starting to provide a full information storage and retrieval system, again without the smart algorithms and analytics that might be available in Climate Pro, for example, but certainly capturing the data storage associated with yield maps and all sorts of things, and making it available in a convenient software platform. They each have different models. It's interesting what's happening in the US is moving towards what they call open data standards. So in other words, instead of you having to sign up to one company and only being able to use data from machines or data from that particular company, they're pretty much all heading towards open ag data access, or the Ag Gateway standard, which means that all sorts of different machinery providers can feed information into that system. So it doesn't matter whether you're using a green header or a red header or a blue tractor, all can feed into that system and the data can be integrated. So, and a lot of them are delivering that product through, for example, agronomy reps associated with input suppliers. So in other words, the farmers have the license for the software, but the agronomist is the one who works the software on behalf of the farmer and helps to make those decisions. Business models, they all started off with a loyalty platform. In other words, I'll put this software to help me sell more of my inputs, but they've now got to the point where they recognise that it's a major new revenue source. So all of them are seeing it as a standalone source of revenue. The systems cost between $3 and $10 per acre for farmers to sign up to. They've all found that cost reduction is a much easier thing to sell than yield gain. And the compliance market is starting to appear in the US, in other words, stewardship arrangements or QA arrangements, but I don't think it's anywhere to the extent that it's moving. That says it's time to stop. Moving in Australia. The target market is, in fact, those of you familiar with the adoption curve, the innovators, what they've identified is these very leading guys don't need the help, that they think they can do better than what the data can tell them. But this group here is the main group that is uptaking the use of this data to help make decisions and get to new production levels. And then the view is that the laggards and the late adopters will eventually follow these guys. So the real focus in terms of the market is this 30 or 40% that may not necessarily be the leading edge, but they're not far behind and are looking for ways to improve their performance. Just in terms of corn, the sort of gains that they've been able to make using this technology, so in other words moving from average for paddock down to average per square metre in terms of treatment, fertiliser, seed rates, etc., around about 5 to 10 bushels of corn per acre, and the numbers work out at an advantage of about $30 to $60 per acre once you take out the cost of about $3 to $10 for the services. So they've had, as I said, quite good uptake on the basis of those numbers. So sort of somewhere between 10 and 20% yield gains and this is stuff coming out of University of Illinois and some of the research centres, not the company themselves. So that sort of explains why the uptake has been quite quick in terms of these services. And this is the sort of model that, you know, prior to data, farmer skill was what mattered. Now we've got data, it's farmer interpretation of that data, and slowly we're seeing computer interpretation of that data become part of the decision-making process. And at some stage in the future, the predictions are that the computer interpretation of the data will become the dominant information used in making farm management decisions, and most of you farmers will be redundant. You'll be able to hand it over to someone else. Whether that gets realised or not, I guess, is an interesting question, but that's the sort of thinking behind a lot of these developments. Data ownership and security. As I said, most of them adhere to this open data standard. That means anyone can develop an app and access the data from various different types of machinery and use it in that app. So that seems to be, whereas in the initial stages they were locking it up and making it proprietary data, now they seem to be making sure it's open. Most guaranteed data confidentiality. I guess underlying this is the reality that if push came to shove and it's a legal case, subpoenas will get access to the data irrespective of what the privacy standards are. So I guess that's a reality of the situation. What are the implications in Australia? We've certainly got less intensive input systems around cropping, and that may limit the potential gains. Retailers and resellers are already using these sort of systems as an input marketing tool. For example, Landmark uses one of these products. Some argue that the lack of detailed soil weather data may limit progress. All of these systems in the US are usually underpinned by very detailed government weather data and government soil data. And the question is whether that's a limiting factor here in Australia. You get different opinions about that. But certainly the productivity potential in changing from paddock management to square metre management is certainly being demonstrated quite clearly in the US, and I guess whether that potential exists and the extent to which that potential exists in Australia is the interesting question that confronts everyone at the moment. And I'll come back to this dilemma that I think all of the industries face, and that is the more protective and restrictive farmers are in relation to the data that they now are starting to collect around their farms, the less likely it is that that will be useful in delivering productivity gains, certainly at an industry level. So the more this data is made available and freely accessible, the more likely it is that it'll be able to bring forward productivity gains for the industry. So it's a real dilemma when it comes down to these issues of ownership and privacy of data, that you know, the more we restrict access to that data, the less likely it is that there'll be insights coming from it that deliver productivity. So I'll leave it there, and I presume we're having questions later or whatever.
Well, a couple of very quick ones, Mick. Thank you very much. If anyone would like to ask Mick anything quickly while he's here. Okay, if not, thank you very much, Mick.
Thank you.
We'll catch up later on.